All right, so we've got our relationship. We've got the Pythagorean theorem. We know that in any right triangle, the sum of the squares of the legs, a squared plus b squared, will equal the square of the hypotenuse, or c squared. So I know a squared plus b squared equals c squared, and I know that works for all right triangles. So let's take a look at a couple problems that use that property. So here we have, Carrie wants to walk to her friend Stacy's house. Carrie's house is over here, and Stacy's house is here. And she could certainly walk 3 blocks up this street and 4 blocks over that street to get to Stacy's house. However, there's also a park right here, and she can cut directly through the park. And I want to know how much less distance she'll have to travel. So I want to know what this distance here is. How many blocks would it be if she walked through the park? And then, of course, how much she will save by cutting through the park instead of taking those streets. So what we basically have here is we have a right triangle, and we've got a right angle right here. And so we can take this right triangle and plug things into Pythagorean theorem. What I basically have are my 2 legs. One leg is 3 blocks, one leg is 4 blocks. And we're looking for the length of the hypotenuse. So I can use a squared plus b squared equals c squared. Doesn't matter which leg is which. I could call the 3 blocks A, or I could call 4 blocks A. Doesn't really matter. So you can choose the order you want. I'm going to plug in 3 for A. So I'll call this one A, and this one B. And we're looking for C here. So I'm going to plug these in. A squared is 3 squared. And I'm going to add to that, of course, B squared, which is 4 squared. And I want to set that equal to C squared. And now I want to solve this equation for C. So 3 squared is going to give us 9. 4 squared is going to give us 16. And that equals C squared. I can add these two together now. 9 plus 16 is 25. And that equals C squared. Now, if I have C squared, and I want to solve for C, we're going to square root both sides. And of course, we always keep in mind that when we square root both sides, we put plus or minus. So I have C equals plus or minus 5. And of course, since we're talking about blocks here, since we're talking about length, for us, the negative isn't really going to have any meaning. So we can get rid of that and just call it positive 5. Again, normally if we were solving the equation c squared equals 25, we want plus or minus 5. But here, 5 blocks is what we're looking for. So that means that this is 5 blocks. Now, I haven't answered the question yet, have I? We found the length, we found the distance from Carrie's house to Stacy's house through the park. What it's asking, though, is how much less she will have to travel if cutting through the park. Well, if she goes up 3 blocks and over 4 blocks, so she walks along this road here, she would travel a total of 3 plus 4 is 7 blocks. And since cutting through the park is 5, that means it's 2 blocks left. So that would be the answer to our question. 2 blocks left, she cuts through the park. Look good? We used Pythagorean theorem. We saw we had a right triangle. We plugged our values in. So, let's take a look at another one. In this next problem, we have a house, and we have a ladder that's resting against the house. We know the ladder is 10 feet away from the house, so they can measure that distance pretty easily. And I know it's a 20-foot ladder. So we want to find how high on that house, on that wall, we can reach with the ladder. So I'm looking for this value here. Now what's different about this problem is that this time I'm looking for a length of the leg, right? I'm looking for either A or B. I'm going to call it B for no other reason than that's what I feel like calling it. So I'll call this side B. We'll call this side A. And we'll call this side, since it's our hypotenuse, we'll call that side C. And we're going to plug these values once again into the Pythagorean theorem. So our Pythagorean theorem, a squared plus b squared equals c squared. So I've got a squared, which we're going to say is 10 squared, plus, this time b is what I don't know, right? So I'm going to put in b squared equals c squared. My hypotenuse is 20, so 20 squared. Now I've plugged things in. Now we need to do a little bit of computation to figure out what our answer is going to be here. 10 squared, that's pretty easy, right? 10 squared is 100. Plus b squared, that's our variable, we don't know what that is yet. And 20 squared is, of course, 400. Now I want to solve for b squared, right? In the last one, we just added the two numbers together. This time b squared is on one side, and I've got plus 100 that I want to get rid of, right? So if I want to get 100 out of there, what I'm going to do is subtract 100 from both sides. So minus 100 from both sides. Again, anything you do one side of the equation, you have to do the other, right? So what I get on the left is b squared. These end up canceling out. My numbers over here. And I get equals 3. So far, so good. Now, again, I want b by itself, right? So at this point, I'm going to take that value, and we're going to square root both sides. So I square root both sides, and I get b. And we do 300, we square root that, and we get, on our handy-dandy calculator, we get 17.3 to the nearest tenth is 0.3205, blah, 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 blah. So 17.3 would be our answer to the nearest tenth, and this is an equal. So I know that that ladder will reach 17.3 feet high on the wall. Sound good? Again, plus or minus normally, but since we're looking at a length here, we're looking at the height on the wall, don't need to worry about that for this problem.